Hello third graders, welcome to lesson 7.2. Today we're going to be exploring 3 different things. So this video will probably be a little bit shorter, but then you'll have 3 different things to go out and kind of explore on your own. Here's the first one. This is the idea of equal shares. So if you remember when we talked about fractions, right? We would count the number of pieces that were shaded, and that was the numerator, right? The top number, and then over the total number of pieces, okay? Now, in order for us to have a real valid fraction, whatever shape or whatever thing, right? Whatever we're dividing up has to be in equal parts. So look at some of these pictures that I have here. Let's look at the first 2 here. This one is divided into 3 pieces, and all of the pieces are equal. At least I tried to draw them equal. I know they're probably not exact, but this is equal shares. Okay. This one is not equal shares. Look, right? There's a little piece, and there's a little piece, and there's a big piece, and there's a big piece. So this one is not equal shares. All right, what do you think about this one? This third circle here. Does that look like equal shares? Yeah, it does, right? And each one is 1/4, 1/4, 1/4, 1/4, 1/4, 1/4. What about this circle here? No, of course not, right? Little piece, 2 big pieces, not equal shares. So this section of this is not 1/3, even though it's 1 out of 3. It's not 1/3 because in order to have fractions, we have to have equal shares, equal pieces. It works with the rectangle too. Look at this one, looks good, right? These are each worth 1/4, 1/4, 2/4, 3/4, 4/4. What's wrong with this one? Yeah, right? It's got a skinny piece here and then 2 bigger ones. So this is not what we would use to represent a fraction. What I'd like you to try, drawing one of each. I want you to draw a shape with equal shares and a shape that has unequal shares. That's not correct. That's not fractions. All right, let's see what we're going to do next. All right, our next exploration here is going to need to be in the kitchen, and you'll probably want to get some help for this. You will need a bowl and then a container that's smaller than that bowl. Okay, so I've got a bowl and a cup. That's probably going to work for you. You're going to take the cup, you're going to fill it all the way to the very, very tippy top. Oh, I spilled a little bit. Let's try again. There we go. All right, second time was the charm there. So now I have this cup filled up with water, and what we're going to try to do here is to learn a little bit about something called volume, okay? Now, when we talked about liters and milliliters, that was capacity, that was measuring liquids. We can also figure out how much space a solid object takes up. That's called volume, not volume like loud or soft. Okay, in math here, volume is the amount of space that a solid object covers. Okay, how much stuff is there. So like these pair of scissors, right? They have a volume. Okay, it's a measurement of the amount of stuff here. And one way that we could measure that is by measuring the amount of water that is displaced. So when I put these, I'm gonna put these scissors in that cup, you ready? When I put these scissors in that cup, some of the water is going to go over the edges. And then we could measure that amount of water, and that's gonna help us to know how much volume these scissors have. See, watch. Did you see some pour out the sides? Okay, I could measure that. Now, if I put in a larger object, right, it's gonna push out a lot of water. If I put in a really large object with a lot of volume, Oh, you have to clean that up, right? So give it a try. Try it out. Make sure you check with your parents, though, before you start dropping things in your water. And you will find our last exploration here today in your math journal. This is page 222. First thing we're going to do here is to estimate how many dots are in the array at the right. Now, remember, estimate does not mean count them all. Okay, we're going to estimate. So looking at this dots, about how many do you think there are? Okay, and then we're going to be making another estimate. It says, follow these steps. Cover part of the array with a square pattern block. Now, you probably don't have a square pattern block if you're at home. So what you can use is use anything that you could use to cover this up. I just cut out some squares, see? And I tried to cut ones that are about the same size. You could use Legos, you could use, maybe your kid brother has some toy blocks. Whatever you get, try to get things that are the same size. And we're going to be covering up some of the dots. Then, about how many dots does one block cover? So I would look underneath this square or Lego or block or whatever you choose to cover it up with, right? You could even use straws or something, long like that. I'm going to count how many are under here. Then B, cover the array. So I'm going to cover it up with all of my squares. Do not go over the borders of the array. How many blocks did I use? So how many of these, or how many Legos, or how many of whatever you're using. And then try to use that. See if once you know these two pieces of information, see if that changes your estimate. Okay, see if that changes your estimate. Today, I know I always tell you to do the try this. You do not have to do this, okay? Because if you want to try to use a calculator to do that, that's fine. But that is not part of the exploration that I want you to do today. All right, good luck with those things.